Okay. Okay. Assalamualaikum to Dr. Nurrehan. Today, me and my team will present our project, which is battery system using MBED 1768. Next. Here are my member. First, Aslinda binti Yunaidi. Second, Nurfahana binti Fauzi. And me, Fatina Laili binti Abdul Aziz. Next. Okay, first. Nowadays, the content of the global heat is getting higher. This situation causes the plant in the environment dry up and die faster. So, because of that, we are planning to create automatic plant battery system using MBED LPC1768. This system is programmed to sense moisture level of plant, whether dry or moist. Next. Okay. LPC1768, which is microcontroller overview. First, high performance ARM Cortex M3 core. Second, ample flash and RAM memory for program storage and data processing. Third, multiple digital and analog input output pin for sensor and actuator interfacing. Fourth, real-time clock, which is RTC for scheduling watering tasks. Next. The benefit of using the LPC1768 based on system. Reliable and precise control of watering operation. Next, efficient resource utilization by avoiding overwatering. Then, scalability and expandability for future enhancement. Lastly, cost-effective solution for small-scale plant care application. Next. Okay, the future of this project is first, soil moisture sensor, which is as an input. Second, MBED LPC1768 as a microcontroller. And last, LED as an output. Next, we pass to Nuraslinda to explain next slide.
Okay, for the block diagram, we have the power supplies, and then our input is a moisture sensor. Our microcontroller is MBED LPC1768, and we have two output, which is LED red and LED green. For the flow chart, okay, we start and then input from the soil moisture sensor. The sensor will read input from the sensor and it will compare if the moisture of the cells detected. If yes, the output of green LED will turn on. If false, the output red LED will turn on. And this will loop in until the power supply is off and it will end. And next is the coding. For the coding, we use area plant watering system. Code readme entry. For plant watering system is our file name. And then this is our main. We use LDR R0 of 1X4002C000 as our pin select. And pin select we use port 0. LDR R1 0X2009C000 for our fast GPIO direction. And then LDR R2 0X2009C018 for our GPIO set. And LDR R3 0X2009C01C for our clear. LDR R4 0X2009C014 our pin. And then R5 LDR R5 we use as our masking pin select, which is our sensor input. So in ARM, input is we write represent as 0 and the output is represent of 1. So because our sensor is input, we use 0. So P5 in ARM is P0.9, which is in bit 9. So in bit 9, which is here, around here, is 0. LDR R6 is 0 x 0000 1 at 0. Masking is our input output for GPIO direction. So this part we declare our input output. So as I said earlier, input is 0, output is 1. So when the binary change to the hexa, we got 1 at 0. The R7 is our masking LED green 1. Sorry, for R7, masking LED green is in bit 8. And then LDRR8, we masking the red LED in bit 7. And R9, LDRR9, we masking it as our threshold in bit 9. In bit 9, so the threshold we use 1. 1 is represent the soil moisture sensor is detected. So I set it as 1. So when it change to hexa, there will be 200. Okay, next we use STR R5. It store in memory R0 as our pin select. And then we store STR R6, our masking of input output in R1. And we use loop first LDR R10 and R4. Load R memory R4 into R10. So R4 is our pin and for sensor to read the threshold. And then as our set our threshold in bit 9, so LDR R5, R9. Memory R9, we load into R5. We use AND operation R10, R10, R5. And then we compare R10 to 0. So we store R8 as our LED red in R2 as set. Mean the LED will on, which is the indicator no moisture. And LED green will off. BEQ loop. BEQ mean equal to 0. If the threshold is equal to 0, it will loop in, and if not, it will go to next operation, which is STR R7 R2. R7 is stored in memory R2, which is green LED will on because the sensor is detected the moisture, soil moist. And then it will loop and end. Okay. Okay, next I will show you in the software, Kill software. So this is the program that I have wrote in the software. So we add the startup LPC1768 and then RTE device. And then this is our file. So we run, first we boot, and there is no error or warning at all. Then we continue to debug it. Okay. So we run the program one by one. So this will represent the input output that we set, and then this is memory that we set. Okay, next I will pass to No, my friend no faham.
Okay, now I will explain about the schematic diagram. Okay, for the schematic diagram, here we have microcontroller embed an XP LPC1768. We have source moisture sensor. We have two LED, which is LED2 indicate to the green LED and LED1 indicate to the red LED. So for the soil moisture sensor, for the VCC, we will connect to the V1, ground to the ground pin, and the DO, we will connect to the pin 5. For the LED2 or green LED, we will connect to the pin 6. And for the red LED, we connect to the pin 7. Next. This this is our result. For the left side, it is show our project when no soil moisture detect. As a picture there, the red LED has given the output. Next, for the right side, the right side of our result, it is show when soil moisture detected. Now we will show how our project function. Sekarang saya sensor tak detect apa-apa. Jadi LED akan menjadi merah. Lepas tu bila detect, masukkan LED akan hijau ke merah. Maksudnya actual product. Okay, for the discussion, from the video, we can conclude that our system is carried out but partially working. It is because our green indicator supposed show using green LED, but unfortunately, LED in some moisture sensor giving the output. We having many error while to troubleshoot the program, but still cannot get the actual result. Next. Uh, so our project can use for real life application, which is for home gardens and indoor plants, greenhouses and nurseries, urban farming and community gardens. Next. So for the conclusion, plant watering system using LPC1768 offers automated and intelligent watering for healthier plants. It is provide flexibility, control and efficiency in various plant care scenarios. That's all from us. Thank you.